Welcome to this lecture in which we are going to talk about network topology. We are going to first discuss the definition of a network topology, and then we will see the different types of network topology. Now, just as topographical map is a type of a map that shows the shape of the terrain, the physical topology of a network is also a type of a map. It defines the specific characteristics of a network, such as where all the workstations and other devices are located and the precise arrangement of all the physical media such as cables. On the other hand, the logical topologies we covered earlier delineate how data moves through the network. Now, even though these two topologies are usually a lot alike, a particular network can actually have physical and logical topologies that are very different. Now, the first topology that we are going to see is the bus topology. Now, this type of topology is the most basic one of all the bunches of technologies, and it really does sort of resemble a bus, but more like the ones that's been in a wreck. Anyway, the bus topology consists of two distinct and terminated ends with each of its computers connecting to one unbroken cable running its entire length. Now, back in the day, we used to attach computers to the main cable with wire taps, but this didn't work all, so we began using drop cables in the place. Now, even though all the computers on this kind of network see all the data flowing through the cable, only one computer which the data is specifically addressed to actually gets the data. For example, if the first PC wants to send data to the printer, only the printer will be able to receive the data because the data is meant only for the printer and not for the nodes. Moreover, the bus topology is very easy to install. If you want to add a new PC, you just have to slip a T into the main cable anywhere you want to connect a device. Bus topology is easy to install and it's not very expensive, partly because it doesn't require as much cable as the other types of physical topologies. But it has some drawbacks. For instance, it is hard to troubleshoot, change or move, and it really doesn't offer much in the way of fault tolerance because everything is connected to that single cable. This means that any fault in the cable would basically bring the whole network down. Now you may be wondering, what is the definition of fault tolerance? By the way, fault tolerance is the capability of a computer or a network system to respond to a condition automatically, often resolving it, which reduces the impact on the system. For example, if something wanks down, the fault tolerance will act automatically to resolve the issue and then bring back the networks to its original position. Moving ahead, now we will have a look at the star topology. A star topology's connections are connected to a central point with their own individual cables or wireless connections. You'll often find that central spot inhabited by a device like a hub, a switch, or an access point. Now don't worry about these terms such as hub and switches. We are going to see all these terms in the network devices section. Star topology offers a lot of advantages over the bus topology, making it more widely used even though it obviously requires more physical media. One of its best features is that because each computer or network segment is connected to the central device individually, if the cable fails, it only brings down the machine or the network segment related to the point of failure. Now, this makes the network much more fault tolerant as well as a lot easier to troubleshoot. Another great thing about a star topology is that it's a lot more scalable. All you have to do is, if you want to add to it a new cable device, just connect the new device to the central hub or the switch and you are done. As you can see on the screen, all the 6 computers are connected directly to the hub. So if you want to add a new computer, you just have to attach the new cable to the hub. Then star topology is easier to troubleshoot because if one PC fails, we can see that which PC has is not responding, and thus we can troubleshoot why the network is not responding. But in this case, if the central device fails, then that is a huge issue. And since it is easier to troubleshoot star topology, more fault tolerance is provided. And although it is called a star topology, it also looks like a bike wheel with spokes connecting to the hub in the middle of the wheel. So to sum up the star topology, here's a list of benefits you gain by going with it. New stations can be added or moved easily and quickly. Then a single cable failure won't bring down the entire network as it did in the case of bus topology. Then star topology is relatively easy to troubleshoot, but there are also a couple of disadvantages to using a star topology. The first one is the total installation cost can be higher, because if you want to add a new device, you will require new cables. And since if there are, let's say, 100 devices in a network, you'll need 100 different cables to connect to the hub. And therefore, there is more cost. And lastly, it has a single point of failure, the hub or the central device. Now that's it for this lecture. In the next lecture, we will cover the ring topology and the mesh topology.